This is a nar probability problem. This is probably going to be the hardest probability problem you would ever look at. You guys ready for this? It is good gnarly. Okay, we have 200 units. See, check this out. We got a manufacturer determined that the average of getting one faulty unit for every 1,000 is 1. So like, what is the probability of getting a faulty unit if you were getting 1,000 units? It's 1 over 1,000. It's 1 over 1,000. So that's the probability. Now it doesn't matter if you have only 200 units or 500 units or 10 units. The probability of you opening a box and that being faulty, like if you just got 1 unit, what is the probability of that 1 unit being faulty? 1 out of 1,000, right? Because every 1,000 units, there's 1 that is faulty. So let's think about that for a second. You get your 200 units. You open the first box. What is the probability of that one box being faulty? 1 out of 1,000. Okay, and so if we're getting exactly 1 that's faulty, that means the rest of them would have to be not faulty, right? Not necessarily. Well, I said exactly 1. If you got 200 units and I'm saying exactly 1 of them is faulty, that means all the other ones will be perfectly working, right? Right?
Wouldn't a factory produce more than 1,000? Therefore, you would have...
No, we're just looking at simple probability. Okay, you got 200 units. You ordered 200 units. The probability of 1 unit being faulty is 1 out of 1,000. That's just the probability of 1 unit being faulty. It's 1 out of 1,000. And this problem says, what is the probability that an order of 200 units will have 1 or more faulty units? Let's just talk about 1. And so I'm trying to find out the probability of having exactly one faulty unit. I have to do this 200 times. There's 200 boxes I have to open. But what would all these other ones be? What would all the probabilities be for these other ones? I have to do this 200 times, guys. I'm not going to do it 200 times, but I'm saying ... right there. If I have exactly 1, that would be 999 over 1,000. And then this one would also have to be not faulty, so that'd be 999 out of 1,000. Because the probability of you guys not getting a faulty one would be 999 out of 1,000. That's a good probability, actually. If you divide that, what's the probability of you not getting a faulty one? 0.99%, or it's 99%, 0.99. That's a good probability. That's not bad. So I wouldn't shut down this factory. But this would equal, when I multiply all these out, this would equal the probability of getting exactly 1 faulty unit. But this doesn't say just what is the probability of getting exactly 1 faulty unit. It says what is the probability of getting 1 or more. So now we have to also find the probability of getting 2 faulty units. So that means this first box and this second box both have a probability of getting a faulty unit. And then I have to do this however many more times for the non-faulty units. Whoa. Are you guys tracking with me? So, do you see the problem with this? Like, if I continue on with this, I have to find out what the probabilities are to getting exactly 1, exactly 2, exactly 3, exactly 4, exactly 5, exactly 6 faulty units, all the way up to 200 faulty units. So this would be ridiculous. This would be arduous. This is when we get this. How to find the probability of a complement. Okay? Now, this right here, the way you would read it, it says, what is the probability of finding not this event? Okay, so what is the event that we want? We want to see what is the probability of getting one faulty unit, 2 faulty units, 3 faulty units, all the way to 200 faulty units. What is not that? What is the opposite of that event? All good ones. That is exactly right. That is the opposite event. So let's find that. If we find the probability of all the units being perfect, we just subtract that from 1, and then we find the probability of the event we're actually looking for. So instead of doing all this stuff, scratch that out. Let's find the probability that all the microwaves are not faulty. So that means we're going to go 999, because that's the probability of getting a not faulty one, over 1,000, and we're going to multiply that 20 times. What do you get? Should be 200, sorry. So it's 999 all divided by 1,000 raised to the 200th power. Let's bust out our trusty handy calculators. Hold on. Questions? Anyway?
What is the ratio of
What?
Why doesn't a ratio maintain?
Yep. That's what I thought too. The first time I saw this. I'm just trying to teach it with.
That's what I was saying. Why doesn't the
That's
ratio?
exactly what I thought.
Maintain the ratio? Why can't you maintain the ratio?
Why does it not maintain a ratio?
Yes.
Isn't it weird how that happens? I think it's because 0.819 is a rounded number.
So